Just sir, sir, actually in a cluster, 20% resources are OS resources and rest are YARN resources, correct?
Not 50, 20%.
Yeah, yeah, 20%, yes, sir. So,
Yes.
sir, basically HDFS storage layer is using OS resources for its operation.
Sir, okay, OS resources means RAM and core. Okay, SDFS
Yes,
will
yes,
use
sir.
disk.
Oh, okay, sir. Okay,
Got it.
got it. Yeah, got it, sir. But sir, RAM and core also like first it will load in RAM, then
So
only it
normally
will write.
storage means disk.
This correct, sir.
Processing means core and RAM.
Core and RAM. Okay, sir. Okay. So basically it is using only disk that to yeah, got it, sir.
Got it, right? Yeah. So okay, next.
Venkat sir, good morning.
Good morning, sir.
So, sir, I have a problem. I'm unable to connect to Namenode UI, sir.
Okay, just share your screen.
Okay, sir. Okay, sir. Sir, able to see the screen, sir?
Yeah, I can see your screen, sir.
This is the problem, sir.
Okay. Okay. But is it working with okay? So it means okay. So if the UIs are not opening, okay, what I told, okay, I have given some steps, right? There is my document.
Yes, sir. I followed, sir. This one, sir.
Okay. Can you go to my document? Is this the document?
This is, sir.
Okay. So this is the document, right? Okay. So have you downloaded this?
Yes, sir. Yes, sir. Yes, sir.
Where is it?
Sure. Yes, sir.
You installed Hadoop, right?
Yes, sir.
Not .++, right? Okay, double click on this one.
Sir, for this issue, just basically we need to make entry in etc host file.
Yes, sir.
Or our name node, then it will work.
It is not opening, okay, host file, sir. It opened now. Okay. So what you need to do?
I need to copy the IP addresses in our host.
Windows host. Control C. Okay. Control V. Okay. Done, right?
Yeah.
Control yes. Yes. Is it asking any yes or no for you?
Yes, sir.
Click yes.
Yes, sir.
Okay. Is it asking anything?
No, sir. Nothing, sir. Thank you, sir.
Control yes. Control W. Okay. So now, okay, you go and check.
Maternity leave lo undi.
It should work.
Hadoop join అయ్యింది.
Saved, right? Looks like okay. Sir, you save it okay, properly. You save it and okay, it will work. Okay.
Okay, sir. Okay, sir. Okay, sir.
Yeah.
With IP address is working, right? No problem.
Yeah, IP address is working, but okay, host name also will work with this.
Okay, sir. Thank you so much, sir.
Yeah. So, guys, any other things? Okay. So if no questions, okay, I'll start my screen.
Sir, name node also working, sir. With the host name also working.
Working, huh?
Yeah, working, sir.
Yeah. Okay, done, sir.
Thank you, sir. Yeah.
Okay, guys, I'm sharing my screen. Okay.
మీరు చెప్పారు కదా ఇదేనా ఈ ఎక్స్ప్లనేషన్ అది తీసుకోమంటున్నారా?
Okay, so yesterday we were talking about different things actually. So what are the different loggings we have? Okay, what are the different logging parameters we have? And what is speculative execution we understood. Then what are the failures? We started with failures in job execution. So any questions in those sessions? Okay. If no questions, okay. So let's understand what is task attempt failure. So normally attempt failure means, okay, normally every task will have, as we discussed yesterday. So every task, let it be mapper task or reducer task, they'll have maximum 4 attempts. Okay. So if first attempt is successful, it will not go to second attempt. Okay? It will not do second attempt. Okay, but okay, by any chance, if first attempt is failed, then it will try for second attempt. If second attempt also failed, it will try on third attempt. Third also failed, it will try on fourth. Fourth also failed. Okay, so entire job will be marked as failed. If any mapper or any reducer, all 4 attempts are failed, okay, entire job will be marked as failed. This is the thumb rule in MapReduce programming. Understood? Or any questions? Huh? Clear, right? Okay. So the first thing is there a task failure. Okay. So let's say, so this is my job. Okay. So here application master is running and okay, mapper 1 attempt 1 is running, or mapper 2 attempt 1, mapper 3 attempt 1, all are running. Okay. But due to some reason, mapper 1 attempt 1 failed. Then what will happen? Automatically, mapper 1 attempt 2 will start in some other machine by application master. Okay, it means, okay, so because of the one attempt failed, okay, your job will not be stopped. Okay, if one attempt failed, okay, application master will identify that attempt 1 is failed, so it will start attempt 2 for the same failed mapper. Okay, so that's how it works actually. Okay, so but okay, so there is something called killed also. Okay, so killed, okay, task attempt may also be killed, which is different from failing. Okay, the reasons for killing. So one thing is that okay, here. One thing is that okay, so let's say okay, speculative execution. Okay, when I say speculative execution, suppose okay, if any map task is running slow, what will happen, guys? If any map task is running slow, okay, so immediately application master will launch a duplicate task. Okay, so let's say here mapper 1 A1 also running state, running, but it is running slow. So immediately application master has started mapper 1 attempt 1 in a different machine. So both places, okay, mapper 1 attempt 1 is running. So okay, suppose okay, if this is completed first, okay, this will be marked as killed. Or if this is completed first, this will be marked as killed. Okay. So that is one. That is about task killed. Okay. So task can also be killed in a different way. Okay. Suppose okay, let's say I'm running a job. Okay. So here okay, these are the node manager services running here. Application master. Mapper 1 attempt 1 is running here. So due to some issue, node manager service is down here. If node manager service is down, okay, whatever the containers running in this machine, okay, let it be mapper container or reducer containers, whatever containers running in this machine, so they all will not work properly. I mean, okay, they all will be marked as killed. Okay, it means okay. See, all these containers are useful only if node manager service is up and running. If node manager is down, okay, what is so all of these things will be automatically marked as killed because there is no one to take responsibility of these containers. That is the reason. Okay, so if node manager any node manager is down, whatever the task running on that machine may be marked as killed. And okay, if any attempt is marked as killed, okay, so will it waste this attempt or okay, it will retain the attempt? Suppose okay, if mapper 1 attempt 1 is killed due to node manager failure, then mapper attempt 1 it will retain in different machine. It means okay, if a task is killed, attempt will not be wasted. That's what I'm trying to say here. Okay. Task is killed, attempt will not be wasted. Okay, but if task is failed, okay, it will start with the other attempt. Understood? Okay. So the next one. So what is the recovery process? Okay, if task is killed or task is failed, in both the scenarios, application master is responsible to reschedule the failed task or killed task attempts, and it will try to not to launch the task on the previously failed node manager. Okay. So let's say due to some reason, okay, the task got failed here. Mapper 1 attempt 1 got failed here. Okay. So now it has to try. Application master has to launch mapper 1 attempt 2. Okay. Will it launch in this machine or a different machine? Normally in a different machine. Normally in a different machine. Understood? Okay. So it will not try to launch under the same attempt, okay, in the node manager, because already one attempt is failed here, so there is no use of there is no guarantee that okay second attempt will be successful here, so it will launch okay the second attempt in a different
అంబల్
machine.
తాగుతాను అంబల్ చేసినప్పుడు తాగుతాను.
Next one. So the next one is application master failure case. Okay, so this is the next concept. What is an application master failure? Okay, let's say this is my situation. Okay, AM failure. Application master failure. Okay, so here, okay, mapper 1 attempt 1 is running. Okay, so due to some issue, application master failed. What will happen? Is there any chance that application master failed? Failure?
Yes, sir.
Huh?
Yes,
So,
sir. There will be.
okay, so like okay, how okay each mapper and reducer have an attempt. Okay, even application master also will have attempt case. Okay? But application master will have less attempts. Okay? Attempt 1 and attempt 2. Understood? Okay? Application master will have only attempts, attempt 1 and attempt 2. Okay, they will not have multiple attempts. Understood? Okay, so each mapper and reducers will have maximum 4 attempts. Okay, but application master will have 2 attempts. It means okay, so here application master is running, means okay, application master attempt 1 is running. Yes or no? Okay, so the attempt 1 got failed due to some reason. Okay, attempt 1 got failed. Okay, it may be out of memory exception, or okay, normally application masters will fail with out of memory exception only. Okay, so what will happen if any application master is failed? Okay, so whom application master will report this? Who will take the responsibility of relaunching application master?
Resource manager.
Business manager, RMC.
Normally, if you correlate with office example, you will easily understand. If employee resigns, okay, team leader will start searching for new employee. Okay, if team leader resigns, manager will start searching for new team leader. Yes or no? Okay, here also do the same thing. Okay, so if application master is failed, then application master heartbeat will not go to resource manager. Now resource manager will try to find some other nodes which has more resources and try to launch application master second attempt. Understood? You try to launch application master second attempt. It can be anywhere. Got it? Are any questions? If application master is failed due to any reason, it will start application master second attempt. Clear? Are any questions? Okay.
So it will be done by resource manager, right?
Yes. Okay. So application master launch will be done by resource manager. Now the question is that okay. So when new application master comes, how new application master will comes? Okay. What are the mappers and what are the reducers? Okay. Okay. So now how new application master will understand? Okay. What is the job? Okay. What is job configuration? Okay. How much? Okay. How much? It is completed. Okay. Okay. So how it will understand? How new application master has come. Okay. How new application master will understand? Okay. What are the say? Suppose I have a job running with 100 mappers. Out of that, okay. So first, as usual, first application master will start. Okay. Then okay. Out of 100 mappers, okay. So let's say 50 mappers started. First 50 mappers completed. Okay. So then okay, we have 50 more mappers in running state. Suddenly application master is down. Okay. RM will launch new application master. Now the question is that okay, how new application master will understand what are the 50 completed mappers, where they stored the output, okay, and what are the running 50 mappers, okay, what is the current status of those running 50 mappers? How it will understand? How it will understand?
From mappers.
Huh?
It will receive heartbeats from mappers.
How mappers will understand this is the new team lead, new application master?
Something similar to standby name node.
But initially itself it failed, yes.
Venkat, before launching Mapper
No.
itself.
Okay, so sir, okay,
Oh.
so I started job 1. Okay, application
Okay, sir.
master started.
Mm-hmm.
So this job has 100 mappers. Okay, 50 maps completed.
Okay, oh,
50 are running
got it, sir.
state. Okay, application master failed. Okay, new application master launched. Okay, what will happen? What new application master will do? Start from scratch or it will continue the job?
I think it will continue the same. Resource manager will launch application master, and then name node manager will inform mapper to report it to.
Oh, okay. Where node manager is having that information? Is node manager maintaining that? Okay, this is for job 1, this is for job 2. No, right?
No.
Node managers are maintaining just information like okay. So how many cores are available? How much RAM is available? What is used to? This is the information. Okay, it will maintain. Yes or no?
Yes, sir. Yes.
Okay, if RM asks, okay, launch a container, it will launch. Release a container, it will release. That is the work node manager will do. Okay.
Yes.
So, okay, then okay, who will have this information?
Resource manager, sir.
What is the job? Okay, so it means what is the job means what is the job ID? So who has this job ID information? If you remember, okay, the same job ID information is with RM in application state, correct?
Yes, sir.
Okay. So now when new application master started, RM only will provide, hey, this is your job ID. Understood? Okay. What is job configuration? You remember, okay. So this application master, okay, when it started, okay, so created job underscore config XML. Sir, no. So if we see job configuration XML, okay, we will understand, okay, what is the job, what needs to be done, what is the input, what is the output, what is the logic, okay, what is the mapper size, what is the radius size, everything I will understand from job configuration XML. Yes or no? Huh? Yes or no, guys? Okay. So where is this job conf XML?
Initially in OS disk.
This is OS disk. Job conf XML and job history JSON, these two files will be directly created on HDFS.
Oh, okay, sir.
So you forgot a yesterday concept or what? These are directly created on these things, but okay, std out, syslog, std error, these are the ones, okay, which will be created initially. Understood? Here directly, okay? Directly created on HDFS location. Okay. But task logs, std out, std error, okay, syslog, okay, these will be created on OS disk initially, then okay, move to HDFS.
Got it, sir.
Okay, so it means, okay, so we have conf XML. So we have, okay, conf XML. Okay, so RM will know the conf XML path. Understood? So RM will provide the job ID and RM will provide the conf XML path. Okay, so it will tell new application master, hey, new application master. So this is the configuration XML. Okay, if you read this configuration XML, you will understand what needs to be done. Okay, and okay, how much it is completed so far. Okay, so RM will provides of his. What is this job history.json file? Huh? So this is the file which contains where mapper 1 is launched, where mapper 2 is launched, where mapper 1 output is stored. Okay, so where mapper 2 launched, where mapper 2 output is stored, where mapper 3 is launched, what is the current status of mapper 3, where it output got stored. Okay, so complete running history. It means, okay, if new application master see this job history report, okay, it will understand, okay, where these 50 mappers are completed. Okay, or where these 50 mappers are completed, and what is the state of, okay, each mapper. Okay, so anyway, it is completed, but okay, where they are stored output, complete information will be available inside this file. You understood what is the use of these two files? These two files are very important for recovery purposes. Understand? If application master is failed, okay, new application master will come and understand, okay, what needs to be done from this file, okay, and what has been done so far and where to start, okay. That will, okay, it will understand that information from job history JSON file. Understood? Understood? Or any questions?
Understood.
Okay. So these are the two files. Okay. So the file path for these two files will be known to resource manager. Okay. It is there in the application state store entry actually. Said okay. Application state store. It will maintain even this path also. Okay. So RM will be knowing these reports information. RM will be knowing what is the job ID, what is the config XML path, what job history JSON file path. Okay. So by looking at these two files, okay, now application master will understand, okay, this is what I need to do. So far this has been done, so I need to continue from here. So here it will clearly mention that, okay, so your, okay, mapper 51 attempt 1 is running here, mapper 52 attempt 2 is running here. Okay, so it will understand who are all, okay, running here, who are all in completed state. Yes or no? Huh? Yes, sir. Okay, so it will understand clearly. Okay, so from here. Okay, so okay, so here the application master failure. Application master send periodic heartbeat to resource manager. And in the event of application master failure, resource man will detect the failure and start a new instance of application master running in a new container. Okay, so it means, okay, if any application master is failed, application master will, okay, there will be no heartbeat from application master. If there is no heartbeat from any application master, then automatically application master will launch a new application master in a different node manager. Okay, but what are the maximum attempts for application master? 2 attempts. And what is the recovery process? So new application master will use job configuration XML and job history file to recover the state of tasks that were already run or launched by the failed application master. Okay, so by using these two files, it will understand what needs to be done, what has been done so far. Okay, so after understanding what has been done so far, it will continue from there. Okay, and recovery is enabled by default in RM. I mean in YARN. Understood? Okay, and okay, if you set this recovery enable property to true, okay, then okay, it will continue from there. But if you set this recovery enable equal to false, then what will happen? New application master will come and okay, start doing the job from scratch. Understood?
Understood, sir.
Yeah. Okay. But okay, if you set the property recovery property to true, recovery enable property to true, then okay, the job will continue from the point of application master failed. Got it? Okay, now I have one more question. Okay, is there any chance of application master kill? What in case if node manager 4 is down? If node manager 4 is down, whatever is running here, it will be application master, mapper, or reducer. Okay? It will be marked as killed, right? So now in this scenario, application master killed. Okay, if this is killed, then okay, will application master waste the attempt? Or okay, it will get the retain the attempt.
Still we have 2 attempts.
It will continue with the attempt 1 only. Attempt will not be wasted because okay, here application master got killed, okay, not because of its own mistake. Okay, it's got killed because of node manager failure. Got it? Okay.
So we can see attempt 1, attempt 2 like that for the naming, sir? No.
Of course, yes, right. Okay, see here. Okay, I will do one thing. Okay, I will take one file and I will wantedly I will do some mistake in that file. Okay, is it fine?
Okay, sir.
Okay, I will show you one. Again, okay. So SDA plus DA plus LS project DLR. Yes, but still. So you asked me to
Sir, how to know the port number
Sir,
of
what are we doing, sir, here?
no, it is failing over, right? Okay. It's failing over, right? Okay. So when I run the command, it is saying fail over, right?
Yes, sir.
It is coming now properly. Okay, so now okay, you take sample5.txt. Okay, so sample1.txt is DFS I1, DFS FXCK, icon files, icon blocks, icon locations, icon maps. So where is it? This is the block number. We have the point command.
Hello.
So we have only one replication copy, right? This file.
మామూలు మెసేజ్ ఓపెన్ చేయి. వాట్సాప్ కాదు మామూలు మెసేజ్ ఓపెన్ చేయి.
I meant dist 185 machine. I meant dist serial. I meant data current finalized. Okay. Okay, I'm just giving one extra space. Means okay, wantedly I'm correcting the block. I corrupted the block. Okay, corrupted the first block. Okay. Now what I will do, I'll run a program here on sample1.txt. Try to understand this. I'm running a job. Let's see what the job ID. Okay, it's running the job. Okay, so this is the job ID. We'll go to Resource Manager UI. Okay, so the job ID is running with 11. Okay, you see. The current status of this job is in running state, correct? Okay, so let's see. Yeah, the final status is finished. Failed. Yes or no? Now let's go to history. Let's go to history. Okay, so how many mappers we have here, guys? 2 mappers we have. Okay, one is failed. Okay, so I told that okay, every mapper will be tried for maximum 4 times, right? So now is it tried for the first time? Attempt 0. It means first attempt. Attempt 1. Okay, attempt 2, attempt 3. Yes or no? Okay, and here we have the reason also. Okay, check some error. Okay, sample1.txt failed date. Okay, so sample.txt has check some error. This is what it is telling. Understood, guys? So do you have the attempt numbers or not? Attempt underscore 3. Okay, attempt underscore 2, attempt underscore 1, attempt underscore 0. So total 4 attempts. 0, 1, 2, 3. Total 4 attempts.
For mapper.
Yes. It's not only mappers are okay. So tomorrow if reducer is failed also, it is the same scenario for reducer also.
Yes, sir.
See here, if you see the second mapper is successful in the first attempt itself. Why okay, attempt 1 is not there?
It's already successful.
It is already successful in the first attempt itself. Okay. But if you see the first mapper, first attempt is failed. That is the reason it tried the second attempt. Second also failed. It tried the third attempt. That's also failed. It tried the fourth attempt. That's also failed. That is the reason it marked entire job as failed. So if you see the final status of the job, okay, it is failed. Understood?
Yes, sir.
Okay. So did it launch reducer? Okay. So even okay, reducer also reduce task also. It is not launched, but still it says it is killed. Can you see this one?
Yes.
Huh? Yeah. Okay. So that's how it works. Okay. So let's do one thing. Okay. So let's change it back.
Second attempt application master will fail also. Entire job will also fail, right? Or not?
Right? A second attempt application master failed also, entire job will fail.
Okay.
Yeah. Okay. So now come to this one. Okay. So if application master killed also, okay, killed due to node manager failure, it will have another attempt action. Clear? Okay. So if both attempts of application master are completed, then what will happen? If second attempt of application master is failed, then obviously your entire job will be marked as failed.
Yes.
Okay. So this is about application master failed. Okay. So now who will recover if application master failed? Who will recover application master? So resource manager will launch a new application master and hand over the conf XML and job history file so that okay, new application master will understand okay, what to do and what needs to be done and okay, what has been done so far. Clear? Okay. So the next one is failures in job execution, node manager. Okay. So what in case if node manager is failed, guys? What in case if node manager is failed? Okay. So node manager failure is serious here. Sorry. If any node manager is failed by crashing or restart, it will stop sending heartbeat to RM. Okay. So here, guys, okay, so let us try to understand the node manager failures. Okay. So node manager failures. Okay. Suppose okay. So here NM3 service is down. Okay. Service or server down. Anything. NM3 service are down or server down. Okay. What will happen? So here think like this, guys. Okay. So application master 1 is running here. Okay. Suddenly the service is down. What will happen? So whatever running here, it will be marked as it will start okay. Same attempt in a different machine. Understood? It will start in same attempt in understood. So if any mapper or any reducer or any application master is failed because of node manager service issue, it will be marked as killed and the attempt will not be wasted. Got my point? Huh? Got my point, guys? Okay. So this is the scenario. Okay. So okay. Now let us try to understand a different scenario, guys. Okay. This is the next scenario. Okay. So here NM4 service is done. Service are server down. Server down. Okay. Service are server down immediately. So if application master running here also, the same application master attempt will not be wasted. Okay. The same application master will be launched on different machine. Okay. We know this also. Correct or not? Huh? When application master is running here, that will be marked as killed and same application master attempt will be started in some other node manager. Okay. If it is a node manager failure. Okay. Now there is a third scenario which is very, very important, guys. Okay. So this is the node manager. Okay. So NM4 application master is running. Mapper 1 is successful. Okay. But mapper 4 is running here, guys. Try to understand. Guys. Okay. What are running here?
Application master.
Mapper also running here. Okay. But mapper 1 is succeeded. Yes or no? Mapper 1 is completed. Okay. But application master 1 and application master, mapper 4, these two are running here. Okay. Now suddenly node manager 4 is down. What will happen, guys? Node manager 4 is down. What will happen? Okay. This is what happens. Okay. So whatever is running in this machine, whatever is running or completed in this machine, everything will be marked as killed. Understand? Even it is completed also, it is marked as killed. Okay. Why I will tell you. Okay. Server or service. Okay. Why I will tell you. Okay. Okay. Suppose now let us take this scenario. If application master 1 is running here, if node manager is failed, application master 1 will be marked as killed, and okay, same application master attempt will be tried and will be launched on different machine. Will you agree with me? Huh?
Yes, sir.
Yes, sir.
Application master 1 is running here, so but node manager 4 is failed. Okay, because of that, application master 1 same attempt will be launched on different machine by RM. This concept we know. Correct or not?
Yes.
Okay. So now if mapper 4 also running here, mapper 4 attempt 1 is running here. Okay, mapper 4 attempt 1 is running here, but due to node manager failure, okay, this also will be marked as killed. Correct or not?
Yes.
Okay. So and the same attempt will be started on different machine. Mapper 4 attempt 1. Okay, but whatever this mapper case, this is already completed, right? Huh?
It's completed means
Completed.
the data already stored in the node.
So it is completed that, but this mapper one output is stored in this node manager. Yes or no? But this node manager is down now.
Yeah.
So even though it is completed, how will you access this output? Because okay, we all know that mapper output will be stored in OS disk. Yes or no? Okay, but if the server down, okay, how can you access OS disk of this machine and okay get the mapper one output? Correct or not? That is the reason. Okay, whatever containers, okay, whether they are running state or whether they are in a succeeded state, everything will be marked as killed, and okay, they will be launched on different nodes without wasting the attempts. See here, application master attempt, same attempt is running here. Attempt is not wasted. Mapper 4 attempt also not wasted. Okay, and mapper 1 attempt also not wasted. Okay, so if somebody asks, okay, is there any chance that okay, mapper 1 is already completed, again it is running? Is there any chance? This is the interview question, guys. Okay,
Yes.
mapper 1 is completed, but again, okay, mapper 1 has come to running state. Is there any scenario? Is there any chance for that? Obviously, yes, right? See here, mapper is completed, but okay, after completion, okay, so this server is down, or service is down. Okay, this node is not available to read the mapper 1 output. Then what to do? What to do then? Obviously, it has to
Launch
rerun.
another.
Exactly. So it has to rerun, okay, without wasting the attempt. Okay. So this is what I'm telling you. If a node manager is failed, okay, so by crashing our restart, it will stop sending heartbeat to resource manager. Okay, so resource manager will mark a node manager as failed, okay, if it is not receiving heartbeat continuously from 10 minutes. Okay, what is the recovery process? Here, any running mapper application master will be recovered by using the previous mechanism without wasting attempt. Okay, or any running application master will be recovered by resource manager without wasting the attempt. Okay, any running mapper task or any running reducer task will be recovered by application master without wasting the attempt. Okay, so but okay, third scenario is that okay, for a mapper or reducer which is already see, if the reducer is already completed, no problem. Okay, because the output is already stored in SDFS. But coming to the mapper, okay, for the completed map task, okay, so application master will mark the completed map task, okay, as failed in that node manager because okay, the intermediate output residing on that failed node manager local file system may not be accessible by reducer. Understood?
Sir, again, mapper 1 starts.
Will start. Will
For-
start.
for-
Yes.
For newly.
Yes. Yes. Again, it will start. Again, it will load the. It will store the intermediate output into local file system.
So if node manager will come to the online, so
No. So
what
this
will
is,
happen?
no. That will be killed, right? That is task is already marked as killed. Okay, then there is no use.
Okay.
Got it?
If same case is with the reducer, then
Reducer means okay, no retry, right? Because if the reducer is already completed, then okay, why you need to retry? The output is already stored in SDFS, right?
yes.
It is
So
not the same case
let
for
us suppose
reducer.
2 reducers are there. One is running, another is completed, and running is succeeded. Like one is succeeded, one is because
still
node
in running
manager.
state.
Yes, another one is still in running.
So completed one, it will leave it. Okay. Completed one, it will leave it. Okay. But okay, the running one, it will mark as kill and it will try to rerun the same in a different machine.
Okay, sir, got it.
Okay.
Sir, so the running mapper task result will be sent to reducer?
Of course, yes, running mapper task. Okay, see, not running mapper task. Okay, see, mapper task output will be sent to reducer only after completion of mapper.
Yeah, because it is running in the other node manager.
No. See, when reducer will take the input, if mapper output is generated, right?
Yes.
If mapper one is still in running, means output is not generated completely.
Okay. So in this case.
Sir, in this case, mapper already completed, right?
No, it's still running in other node managers, right?
Okay, so let us take this scenario. So you have two mappers. Okay, so mapper 1, attempt 1. Okay. Mapper 2, attempt 1. These are the two mappers. Okay. Now we have one reducer. Okay. When reducer 1, attempt 1 will start.
Yes. It has to get output from.
Okay. So it should start. Okay. So complete, generate output. Yes or no?
Right.
Start. Okay. Complete. Completed. Started. Completed. Okay. Output generated. Output stored in LFS, local file system. Yes or no? So now this is the input for
Reducer 1.
reducer, correct or not? Okay. Next, started, completed, output stored in LFS, okay, and released. This is what the status now. Okay. Now tell me when reducer will start.
When
Only
M1
after
What is LFS, sir?
these two steps, right?
Yes.
Huh?
Yes.
Yes or no? Now you are saying, okay, the mapper is in running state. Now tell me. Running means okay, still here only, right?
Yes.
Then why reducer will start? Reducer will start accessing this output only when it reaches this level. Mapper 1 is running means okay, still it is at this stage. Got it?
Yes.
Yeah.
So,
okay.
So the output of mapper is stored in data node, sir, or node, data node?
Data node local file system.
Okay.
Local file system, data node OS disk. Otherwise. Okay.
Yes, sir.
Okay. Yeah. Okay. So this is how, okay, you will be having the node manager recovery will happen. Okay. The last one is what in case if RM itself is failed? What in case if RM itself is failed? Huh? Tell me, guys. The failure of RM is serious. Without it, neither new jobs or new task containers can be launched. If RM is not there, okay, no new jobs can be submitted. Because, okay, if anybody submit any job, okay, first point of contact is resource manager. If resource manager is not there, okay, can anybody submit new jobs?
No, sir.
No. Okay. So let's say, okay, so nobody can submit new jobs, but what about the existing jobs also? Application master need containers. Okay. Who will approve the containers?
Resource man.
But resource manager is not there.
Yes.
Then, okay, so then no new containers can be launched. Yes or no? So if your job is already assigned with the containers, your job will run. Otherwise, okay, your job will be on hold. Yes or no?
Yes.
Okay. So in the default configuration, RM is a single point of failure. Okay. So in the default configuration of Yannick, RM is a single point of failure. But however, okay, single point of failure. Okay, and in the event of RM failure, okay, whatever the running jobs, okay, will be marked as failed. Okay, if you have only one RM, if that one RM is down, okay, whatever the jobs that can running state, all those jobs will be marked as failed, and okay, they cannot be recovered. Okay, if you submitted a job, okay, and it is 50% completed, suddenly RM is down. Okay, so your job will be marked as failed, and okay, you'll have to rerun your job once again from scratch. Understood? Understood? Are any questions?
Understood.
Clear, right?
Yes.
Yeah. Okay. So to achieve high availability in RM, okay, so in RM, it is necessary to run a pair of RMs in active standby mode. If active RM is failed, and okay, standby RM will come into picture. Correct or not? Correct or not, guys? Okay, so now to achieve high availability, okay, we need two RMs, RM1 and RM2. Resource manager 1, okay, two RMs running in different machines. Resource manager 2, okay, and resource, okay, so one will be acting as active and one will be acting as standby. Okay. So who will act like active and who will, and who will decide who should be active and who should be standby?
Zookeeper.
Zookeeper only, okay. So zookeeper.
Same zookeeper we will utilize here also.
Yes, the same zookeeper you can use.
Okay, got it. Yeah, thank you.
Okay. Same zookeeper you can use here. Understood. Same zookeepers, okay, you can use to decide who should be active and who should be. Okay. Okay. Now, okay. So what about JetKFC? Okay. For name node, okay, we have JetKFC right in between.
Yes,
Sir,
sir.
one
Yes,
question.
sir, no?
Yes, sir.
Sir, 1 second. Let me complete. Okay.
Okay.
So for name node, okay, we have in between okay, JetKFC. Okay. So here, if I see the same case with the name node, or no? Is the scenario right for name node? Huh? So name node is a master node. Okay, it's a master service. Okay, JetKFC one will be collecting the status and okay, and sending it to Zookeeper. In the same way, JetKFC 2 will be collecting the status of name node and sending it to Zookeeper. Are we clear? Are any questions? Huh?
Clear.
They're clear, right, on this point? They're clear on this
Yes.
point. Okay. So JetKFC 1, okay, JetKFC 2. Okay, but here when it comes to RM, okay, so these JetKFCs are PS for name node. It means they work only for name node. Okay, they will not work for RM. Okay, but okay, so but okay, who will send heartbeat Zookeeper now? RM heartbeat. RM also master, right?
Yes.
Yes, sir.
Okay, so here, okay, so here RM will have inbuilt JetKFCs. So you will not have separate JetKFC for RM. They have inbuilt JetKFC functionality actually. Okay. So that inbuilt JetKFC functionality of RM will be sending heartbeat of RM to Zookeeper. Understand? So when you are running two RMs, you don't require extra JetKFC. Okay, JetKFC is already part of your RM resource manager service. Understand? But okay, so for name node, okay, JetKFC is a separate functionality. Okay, separate service. It will be running like separate service. But here, so no need of JetKFC. But okay, so here, okay, same Zookeeper, right? These are the same Zookeepers here. Yes or no?
Yes.
These are the same Zookeepers here. Okay, so you can say like, so if it is confusing, then okay, you can say, okay. Understood? Understood, guys? Okay. So both RMs will use same Zookeeper to so it means Zookeeper will be used to decide okay, active RM, standby RM, and active name node and standby name node, both. Clear? Clear. Are any questions? Okay, it is clear. Okay. So now the question, okay, so now when you have two RMs, okay, yes, active standby can be managed by Zookeeper. Okay. Now when you have two RMs, how both the RMs will understand okay, what is the job done by, what are the jobs executed by RM1? Okay. So if RM1 is failed, okay, how RM2 will understand what is being done by RM1? So okay, whatever the new application comes, like RM is storing in the application state store. Yes or no?
Yes,
Yes or
sir.
no? State store. Okay. So Okay, so each RM will maintain cluster state store also. Okay. What is application state store, guys? Whatever the application state receives. Okay, whatever application state received. Okay, so whatever the received and executed. Okay, so whatever the application received by RM, okay, and execute whatever jobs executed by RM, that will be maintained in the application state store. Whatever the job executed by RM2, and that will be maintained in this application state store. Okay, but if RM is failed, how RM? Okay, other RM will understand okay about these jobs. They will not write. Correct or not? See, if you write okay your jobs in your own application state store, if I write my jobs on my own application state store, okay, how will I understand your jobs and how you will understand my jobs? Correct? So what is the solution here? Instead of keeping state store here, okay, so put in a common place. Understood? This is what we have done, right? Even in name node also.
Yes, sir.
One local copy, one common copy. Who are maintaining the common copy in
General node.
sorry general nodes? There, okay, the common copy of edits were maintained by general nodes. So here general nodes are only meant for storage layer. They are not meant for processing layer. Okay, so now the question is that where to store this one application state store.
So is there any checkpoint happens here?
Okay, so I need to maintain this application state store in a common place. Okay, so where to maintain this one? Okay, one way is that okay. See, if you want to maintain this one, okay, so you can maintain in a shared network drive. One is network drive. Okay, but network drive will have only one copy. If that one copy is gone, okay, gone case. Okay. Better to store this file in multiple places because this is very, very important file, right? This will have information like okay, what are the jobs submitted? Okay, so we need to maintain in a safe place. Okay, one place okay to maintain this one is okay. So SDFS. Yeah. So why SDFS? Whatever you store in SDFS, that will have 3 copies. Yes or no? Yes or no, guys? This is one way. Okay, you can store this application common copy of application station inside SDFS. Okay. Okay. If not, okay, if you don't feel that SDFS is not good, then you can store into use Zookeeper to do this one. So this is SDFS. Okay, this is like on disk. Okay. This is Zookeeper. Again, this is on in memory. Understood, guys? One thing is that I can store in SDFS, or I can store in each Zookeeper. Okay, each Zookeeper memory I can store. I can use this one, right? Sir, no. These are the 2 ways where I can store this common copy of application state store. Okay. So now, so information about all the running applications is stored in highly available application state store, either maintained by Zookeeper or SDFS.
Sorry.
Okay. So for the standby connector, so in this scenario, active name node is down. So whatever the jobs submitted to.
Sir, this is continuous. Yes, like see application state store and cluster state store. Anytime these values means RM can get. Means memory is sufficient.
How
yes,
application state store can get.
Okay. Yeah, that is that is
Okay, see, if you restart, okay, every node image will send heartbeat, okay, and they will send this information. Correct? Yes or no? If you restart, okay, every node will send this. Okay, this can be reconstructed. Okay, but this application state store, who submitted what job and who will remember? So who will
Yeah,
tell
yes, yes.
I have run some jobs on March 24th. Who will tell? Okay, who will give me those jobs? Huh?
Yeah, got it. Yeah, application state store we need to store somewhere, correct?
Yeah, that is the reason we are storing application state store in a common place with multiple copies.
So locally also it will keep it in memory RM
One copy,
and
sir. Yes.
okay, sir.
Okay. And this is the one. This is on disk. This is in memory. Okay. If you
So
go
in
with
all three places it is storing Venkat, like
yes.
okay, sir. Got it.
Okay. Clear. Okay. So if you want to enable resource management availability, okay. So this is the resource manager. Okay, limitation of single resource manager. So if you see resource manager, okay, this is RAM actually. This resource manager will store application state store, cluster state store. Okay, both the informations. Okay, but okay, if resource manager is down, okay, both will be lost. Okay, but okay, so there are two ways to maintain the resource management availability. One is Zookeeper based one, and other one is file system based state store. Okay, so Zookeeper based.
Any one we need to use, sir, or both we can at a time.
You need to use any one, not both. Any one. Okay, any one is fine, right?
Yeah, any one
if you
is
use both, okay. If you use both, what will happen? Total 6 copies will be there. Why you want
already? Yeah.
Got it.
Either it's
you use any one, that is fine.
But sir, if it is keeping in Zookeeper and in its local copy, and in that case, because Zookeeper is keeping in memory only, correct?
Yes.
If cluster restarted, that will go off. Yes.
Okay, so if Zookeeper is restarted, yes, that will go off. But okay, you have so many Zookeepers, right? Multiple Zookeepers, right? So you are confident that okay, nothing will happen. Okay, at any point of time, okay, all Zookeepers will not go down. That is what your confidence.
Yes, that is correct. Yes.
Got it. Okay.
In case of rolling restart, like if we are doing one by one Zookeeper restart, in that case it will go. This copy will go. Yes.
No. If you do rolling restart, okay, when any Zookeeper is launched, it will become follower. Yes or no?
Yes, follower. Correct.
Follower will sync the data from leader.
Okay, sir. Okay, got it. Yeah. Okay.
So no need to worry about that.
Sir, one more doubt here.
Yes, sir.
So for job by job, it will store the app state store, sir. Or is there any time?
As soon as you submit a job, immediately there will be an entry in the application state store.
Okay.
Got it.
Okay, sir.
Okay. So here there are two ways. One is Zookeeper based and a file system based. Okay. So Zookeeper based is faster because so when active RM is down. Okay. Why I am saying Zookeeper based is faster because if active RM is down, okay, standby RM will read application state store from memory. Yes or no? Reading from memory is very fast when compared to reading disk. Okay. Suppose if you are using you are storing application state store in HDFS. Okay. Then what will happen? What will happen? If active RM is down, standby RM have to read. Okay, standby RM has to read the data from HDFS. Application state store information from HDFS. Okay, reading this data from HDFS. Okay, may take some time. Okay, so that is application state store is very faster, but the problem is that if all Zookeepers are gone, okay, this will be gone. Okay, but application state store storing in HDFS is very good. Okay, even though you restart, also nothing will happen to your job information. But only thing is that it is very slow to load.
So which one is preferred, sir, in real time?
It depends on the company. Okay, but we are using file system based state store. Okay. Because we submit we submit 3 lakh jobs in a day. When I say 3 lakh jobs in a 1 hour, how many jobs will be submitted? 1 hour. 12,500 jobs will be submitted. Okay. 12,500 jobs means so per minute how many? Not 8 jobs. Okay. Suppose if I don't maintain this jobs information in a permanent in a good place, okay, I need to ask these 208 people to resubmit their jobs. Yes or no? Yes or no, guys?
Yes, sir.
Per minute, okay, 208 people. Okay, so they have to resubmit their jobs. Instead of that one, okay, even though recovery is a bit slow, not a problem. Okay, I don't want my users to resubmit their jobs. Got my point?
Sir, also one point, sir, like they will have the local copy also, sir. In case of recovery only, it takes time, right?
Recovery only, yes.
Normally it won't take time because all running job will be very faster. It's having local copy as well.
Yes, sir. Yes, sir.
So recovery will happen sometimes in once in month, I think so.
Yes, sir. Okay. Yes, you're right. Okay, but okay, do you think RM will fail, okay, every day? No, right? Hardly it will fail. Okay. So this is the idea, guys. Okay. So here, so we are using Zookeeper to maintain, okay, active and standby. So here, okay, there is something elector, right? I told you, right? Inbuilt JetKFC. That inbuilt JetKFC is nothing but elector here. Got it? Elector is the one who will be sending heartbeat to Zookeeper, and Zookeeper will be will decide who should be active and who should be standby. Okay, and Zookeeper is also maintaining, okay, RM state store. Got it?
Sir, what is NFS?
Network file system, common shared drive, madam. You can put this in shared drive also, but if you put in shared drive, you'll have only one copy, not 3 copies.
Okay.
Got it? Okay. Shall we implement this and see? Okay. So if you want to implement this one, okay, let us implement this. Okay. So
sir, one question regarding the issue you faced, failover. Sir, is it frequently happening in the cluster? Failover, whatever you faced recent, like just now, just before this?
No.
Okay, not happening. So because what happened today means I also submitted. I also got failover, and after some time, when I retried, same job went fine. I don't know what happened in the middle of this cluster. Like
that's what, sir. Okay, see, if you have multiple resource managers, okay, if job is okay, suppose okay, 50, you submitted a job to resource RM1, job is 50% completed. Okay.
Yes, sir.
If suddenly RM1 is down, RM2 will become active and it will continue your job from 51%. It will not stop.
Okay, sir. Got
That's the beauty, right? Otherwise, what is the use of 2 RMs? One RM is down, other RM should continue your job.
Got it, sir. So maybe there is a probability that failover happened because of maybe RM went down or something. Yes, like kind of.
Yes.
Got it, sir. Thank you.
Okay, shall we implement practically? I'm just opening, okay, this one. So here for RM, okay, I'll put it one more ID, 182 also. I'll go with 2 RMs concept. Okay. Good. Okay. So open on-site XML and delete these entries. What are the entries? Delete these 4 entries. Okay. And add below entries here. Add below entries. So let's see what are the properties we added here. Okay. So the properties we added are this one. Okay, so first, okay, HA enabled equal to true. Resource manager HA enabled equal to true. Okay. What is the cluster ID? Common name for both the resource manager. Again, here I've given my cluster. Okay. Under my cluster, okay, we have how many RMs we have. Okay. So these are the RMs. Okay. So what is the first RM IP address, second RM IP address, all these things. And what is the Zookeeper also I have given. Okay. So then, okay, what is the failover proxy provider also I have given. Okay, recover enabled equal to true I have given. Okay. So, okay. So where to store? My application state store also I have stored. Okay, JetKRM state store. Okay. So now validate the XML. Let's add one point here, validate XML. This is always better. Okay, so this will make sure that okay, you have not committed any mistakes. Okay. So we changed YAML site, right? Icon site XML. Yes. Okay, XML is valid. Okay, now put this valid XML to another. Okay, now restart resource managers. So I'm restarting. I'm stopping the existing resource manager and stopping the existing node manager and starting the new resource manager and new node managers. Okay. Now let us check what is the get service data RM. Both are standby, right? Why both are standby? Okay. What is this? This we are using Zookeeper quorum with forward flow. Zookeeper are running, yes, right? Zookeeper quorum remains quorum, yes. They are running. The resource manager also running, Java system is running. One more resource manager also running. Okay. Okay, then what is the problem? Why both are standby?